Looking at steady input can physically regulate your autonomic nervous system state. It is not just about focusing better. Focused vision is actively shifting the balance of stress and calm within you. When we sustain smooth, stable gaze, it correlates with a parasympathetic downshift. Think of that as turning your body's internal thermostat towards safety. This visual entrainment is not passive at all. Your eyes become highly functional feedback devices connecting subtle movements to deep neurophysiological shifts in the brainstem and beyond. We can use principles from oculomotor science to optimize flow states by measuring how our gaze relates to genuine autonomic tone. Understanding this connection moves us past vague concepts of being focused toward actionable biometric reality. Full research archives are available at jmthomasofficial.com. When your eyes are engaged in sustained, stable tasks, specific neural networks begin communicating differently. We are not just seeing. We are actively regulating our central attentional machinery through the oculomotor system. For instance, research shows that functional connectivity between visual processing centers and frontal control regions is highly modulated by how stably you maintain gaze during focus tasks. This is not passive observation. It suggests eye movements can act as an instantaneous biofeedback loop influencing prefrontal cortex activity itself. By quantifying these minute shifts in tracking precision, not just reaction time, we gain a measurable proxy for your internal cognitive workload and true nervous system state. Subtle changes in your resting eye movements are far more telling than active focus tasks suggest. Consider how the natural instability of vision, like nystagmus or eyelid flutter rate, relates directly to baseline brainstem function. This is not merely a visual hiccup. It is an observable marker of deep autonomic state control. These micro-movements signal fundamental shifts in central nervous system regulation over much longer temporal scales than saccades alone can convey. If we can read these incredibly slow physiological signals, we gain access to the chronic patterns governing our overall stress resilience and energy availability months down the line. How deeply does that minute shift truly connect? You need to see what happens when this microscopic process meets systemic endocrine timing. It fundamentally changes everything you thought you knew about stable focus. The clockwork governing these minute movements does not run in a vacuum. It synchronizes with your deepest endocrine timing cycles. How our natural resting eye rhythms interact with cortisol release or the circadian rhythm introduces an entirely new variable to focus optimization. Some laboratory datasets indicate that elevated stress hormones actively disrupt stable gaze patterns, effectively jamming the autonomic feedback loop we observed earlier. Conversely, other research suggests these subtle shifts become adaptive mechanisms of resilience under specific systemic timing pressures. Which factor dominates? The internal hormonal chaos or the focused visual attempt? The data conflict forces a profound question about control itself. Perhaps our perception of sustained calm is conditional on where we are in the daily biological rhythm cycle. You need to see how this integration fundamentally changes the rules of deep focus. How do we measure resilience when the system is failing at its most granular level? The instability hinted at earlier, those microfluctuations in resting eye movements like nystagmus or blink dynamics, are not just indicators. They function as immediate proxies for core brainstem regulatory integrity. They signal whether your foundational autonomic control systems are holding steady under pressure. When hormonal stress throws the system out of alignment, these tiny visual patterns become noisy signals showing genuine neurological strain. This goes far beyond simple focus problems. We are observing a barometer of systemic vulnerability over long time frames. If we can interpret this biological chatter from sub-second eye movements, we gain access to chronic stability data that conventional measures miss entirely. But the deepest question remains: is this instability merely a symptom, or an exploitable signal leading directly toward profound states of control? The synchronization we are observing is not just a reflection of your current state, or merely an external influence on focus. It points towards something more fundamental: how visual rhythm may be directly coupling with core metabolic efficiency within neural circuits themselves. The idea that stable eye movements improve calm is only half the picture. True stability might actually be governing mitochondrial health in specific brain regions, a direct line from your sustained gaze to cellular power generation. We assumed optimal focus meant minimizing noise, but what if achieving this deep state requires a precisely orchestrated oscillation? Does this coupling demand absolute stillness, Or does it require finding the perfect rhythm between micro-movements and systemic timing? Movement itself holds a hidden command structure within your brainstem. We were focused on finding absolute stability, treating any micro-movement as noise to be suppressed for peak function. But the data suggests that is fundamentally wrong. The optimal state is not zero movement. It is achieving specific resonant frequencies across multiple time domains simultaneously. Imagine the visual feedback loop does not just regulate calm. Its inherent oscillation acts like a tunable bandpass filter, selecting only those cognitive inputs necessary for deep processing while rejecting extraneous signals. This suggests that certain controlled rhythms in gaze are actually forcing local neural circuits to operate at peak efficiency by actively tuning out chaos. We assumed we were stabilizing the system when perhaps we should be optimizing its frequency of operation entirely. What this means for your sustained focus is a massive conceptual shift about movement and mastery itself. The data ultimately reveals that control is not the enemy. Specific biological resonance is your true guide. We are no longer searching for perfect stasis, but rather finding the precise oscillation frequency where visual input optimally aligns with deep nervous system timing. Think of it as dialing a radio station. If our eye rhythm matches the body's internal metabolic cycle, we achieve maximum signal clarity, that is peak focus and systemic calm occurring together. This allows you to measure whether your gaze is in sync with your most effective physiological state for resilience and deep work. To find these exact patterns, their underlying methods, and the full research archive used here, visit jmthomasofficial.com. The final verdict is profound simplicity in a complex biological system. Your goal should not be rigid stillness, because that ignores the essential dynamism of life and function. Instead, you are searching for resonant coherence, when your gaze oscillations find their harmonic match with the body's internal metabolic clock. This synchronization creates an optimal energetic throughput within neural pathways itself. To apply this knowledge practically, observe microgaze stability during moments of high cognitive load. The goal is finding that specific frequency of motion that supports maximal clarity and calm simultaneously. For complete access to these quantitative methods, figure breakdowns, and source citations, visit jmthomasofficial.com.